I started in 2012. It was right after I did my postdoc in the University of Georgia in Athens, and I was hired as a research geneticist by the USDA in sorghum in Lincoln, Nebraska. I felt confident that I could handle it because I had studied under a corn breeder at the University of Wisconsin-Madison, Natalia de Leon. She's very famous. I was one of her first grad students, and I knew that sorghum was similar to corn, and so I figured that that would be an okay thing for me to do and still be able to earn money for my family. Well, I've been at the University of Nevada, Reno, which was my first tenure track position available to me in academia, which I decided I liked a bit better than USDA or private companies. And so I've just finished 8 years. Well, I'm soon to finish 8 years there. And so we're reaching to the point of being able to commercialize our first products, inbred lines and hybrids. And to support that, I needed to be able to give my publicly available germplasm that I've developed at the university to a private company that could then commercialize it. But the issue became that there were no private companies working on sorghum breeding for specifically Nevada and California. There are companies that have land in those parts of the country, but unfortunately they're not using it to adapt to new varieties. They're just using it to screen varieties that are being adapted to other parts of the country. So therefore, if I wanted to preserve all of the local adaptation traits I had worked on through my university grants, then I needed to start my own company to be able to commercialize them. So that's what's really changed. And we actually have farm trials all over the country right now. So it's very exciting. So sorghum is one of the top 5 produced cereal crops in the world, and it's the only climate-smart species on the list. So if you look at some precision business insights, some market reports, end-use quality is a trait, a suite of traits really, like baking quality, fermentation, stuff like that. End-use qualities are very susceptible to climate change because historically people have bred wheat and barley and other things that are used for grains, for baking, brewing, and other things. They've developed those varieties within very specific regions, but now with climate change, the boundaries of those regions are changing. And when it becomes too hot or too dry for those are cool season grasses, when it becomes too hot or dry for them, we don't currently have anything to replace them. And so this is where sorghum is, what I'm working on in my lab is to be able to develop sorghum, which is more heat and drought tolerant. It's a C4 grass species, to be able to express the same baking quality, brewing quality traits as wheat and barley, and then adapting them to these locations where wheat and barley are currently growing so that the farmers have something they can transition to when it comes to that in the future. Certainly the western part of the United States is experiencing more dramatic climate change than other parts of the country, and generally speaking, Reno is the fastest changing city in the country. Our average temperature has changed by like 11 degrees in the past 10 years or something like that. As an academic, I saw establishing my breeding program here based on end-use quality as a very strategic decision because the premise is if we can de novo adapt a species with desired traits in these super hot, dry environments, some of the hottest, driest agricultural production regions in the world, if we can do that here as a proof of concept, we ought to be able to do it almost anywhere. So okay. It's really just kind of proof of concept. Sorghum is definitely going to do better in places that are hotter and drier. It's not very well suited to a place that has cold, wet springs. It doesn't like cold soil in general, although there are some breeding programs that are focused on improving the cold tolerance of sorghum. But as a general crop, that's not really where it's well suited. So if you would just imagine anywhere in the world really that is struggling with hotter, drier temperatures and its existing cereal crops are not doing well, sorghum would be a good option to try. Most sorghum breeding research in the U.S. is centered on the Great Plains, and especially the southern Great Plains. So Kansas, Texas, Oklahoma have a lot of sorghum breeding programs. That's what we would call the sorghum's adaptation zone, primary adaptation zone in the U.S. Although there are other programs, like up in Indiana and Georgia and South Carolina. But again, those breeding programs would sometimes screen their varieties to see how they do in California, just as kind of like, just get an idea of G by E interactions. But that's very different than adapting it to perform best within that environment. Mm-hmm. So that's really the specific niche that Yerka Seeds fills for sorghum. Mm-hmm. So most sorghum outside of Africa, which is where it was originally domesticated, is used for animal feed. So here in the U.S. it's mostly used as animal feed, both as like a silage, a forage, and then as a grain to feed to like pigs and ducks. Most U.S. sorghum is exported to China currently. I'm not sure how the current tariff environment is impacting that for the moment. And also sorghum is an emerging biofuel for grain biofuels, especially in Kansas. There's a number of ethanol plants that will take it. People are working on fermenting the biomass into ethanol, so it's a biofuel species that way. In Brazil, sorghum, the sweet varieties are crushed to extract the sap, and that works as an ethanol-based biofuel in the off-season when sugarcane is not being produced. So again, mostly in the world it's a biofuel or it's for animal feed. Traditionally, sorghum was domesticated by folks in a couple of different regions of Africa as a food, but it was always used for animal feed as well. And what's unique about my program is that, again, I was very interested in this question of, we have a grass species, we know it has food quality potential based on its domestication history. It just hasn't been used that way in the U.S. And so can we, in parallel, adapt it to these new environments, but also introduce these food quality traits that I think are really going to take off with the increasing interest in gluten-free foods. So obviously you guys are in the business of, controlling pollen and protecting grain from birds. And so we've been using your guys' mesh bags for several years now. I think we're pretty early adopters in the U.S. And that's because I was just actively looking for something that I could use, because we are interested in grain quality traits. And of course, any sorghum breeder knows if you put the traditional paper bags on top of the panicle to prevent pollination, a lot of times the grain will just form differently inside there than it would in the panicles that are open pollinated. And so I definitely was looking for years for something else that I could use that would allow more air circulation. But of course, the question is, are we going to then get pollen through there as well? And we can confirm, after we've been using your bags now since 2022, I think it's the first year, that we have used male sterile plants and confirmed we get no cross-pollination. And we do also get very similar grain chemistry profiles. The only difference is that in our open pollinated panicles, they'll develop more color. Whereas the ones in the mesh bags will develop a little bit less color. However, the ones that are in a paper bag, which is normal, they would develop even less color still. Okay. So we found it to be a good trade-off between making sure we've got the grain chemistry stabilized in our breeding program within a particular variety, while also excluding the pollen. And what we have figured out to do is that we will, if we're really interested in the potential of the variety to accumulate metabolites that are going to influence flavor, that's a color-based trait, not exclusively, but it's definitely influenced by that. We can allow a plot to have some open pollination just for that trait, but then we'll also have the mesh-covered panicle within the plot that we can compare the various starch chemistry to. So for example, we work a lot with low amylose content, which is sometimes called the waxy trait. It's very important for fermentation and digestibility. It's a recessive trait. So by looking at the grain chemistry of the ones that are covered by the mesh panicle, at the amylose content in those plants versus the ones that are open pollinated, we can kind of get a sense of how much cross-pollination occurred in that plot. And what we've recently discovered is we can use that differential in a GWAS to actually identify genes that are associated with less cross-pollination. So it's turning out to be this kind of innovative opportunity for finding ways to develop varieties that just don't get outcrossed as much. For any kind of fermentation application, so if you're breeding a biofuel that's a grain-based biofuel, you want a low amylose content because that starch is going to ferment more efficiently into ethanol. But if you think about it, when you're fermenting beer, that's ethanol. When a cow is fermenting stuff in its rumen, that's a fermentation process as well. So anything that involves fermentation is going to be benefited by that, by the waxy trait. Yeah, the primary thing was that we verified that we don't get cross-pollination if we use the bag. So we know for a fact it's going to exclude pollen while still allowing airflow. We saw that the grain just physically looked more plump and healthy when it was under a mesh bag than a paper bag, because it just wasn't so desiccated and it didn't get so hot. I think sometimes the paper bags make it a little too hot in there for the grain as it's filling. So just making sure that we got good seed chemistry that was not outcrossed was very important. So that's how we decided that we were going to continue to use the bags. So we always include a Texas environment when we're doing multi-environment trials as kind of like an environmental control, because that's where sorghum is kind of mostly centered. North Texas, the Lubbock area in particular. And they have a lot of birds there if you grow the sorghum close to town, and they'll just decimate the crop. In Reno, at our experiment station on campus, there's a lot of trees and fences that the birds will sit on, so they'll take out the crop as well. Last year when we did our first trial at Davis, California at the university site, we didn't have very much bird pressure because they have just more of like an open field and the trees are further away. But definitely the mesh bags help with reducing bird pressure. And in terms of mold, in these really dry environments that I'm working on, we don't have a lot of mold. Lubbock will get a bit more than Nevada and California just because it does get some rain in the fall when the grain is mature. But it's a pretty dry environment, so the grain quality is pretty good. This year we're having our first trials ever in like upstate New York, and so that's going to be more humid, and we're just going to see how things go. Because I'm breeding for grain quality traits and flavor figures amongst them, and obviously like protein and digestibility figures in there too. If I notice that a particular variety is being especially attacked by the birds, then I will put a note on there that there must be something good about it. So it's almost like, participatory plant breeding with the birds. Yeah. No, I haven't quantified bird damage other than to just kind of make that note if the birds really like something. And in terms of like mold damage, we haven't tried quantifying that because we just don't see a lot of it in our materials. In terms of the color development, we are in the process of quantifying that for the first time, the difference between an open pollinated and a mesh covered panicle, based on the field trials we did in 2024. But that data analysis is still ongoing. And what we're using is just like a colorimetric sensor, and we're just scanning the grain and comparing the C lab values across the open pollinated versus mesh covered bags. I recently saw, I think on LinkedIn, you guys have like tents that you can use to cover plots now. And I haven't heard much about them before, but it looks like a pretty good idea.
Yes. Yeah, so we have these pollination control tents that are designed to be modular. So there's a standard footprint, which is 1.5 meters by 3 meters. And then they're designed so that you can join them to each other in different combinations, so that depending on from year to year what you need, you can adapt. So they're designed to be an investment, so the framework lasts for about 10 years, and the panels, depending on the climate that you're using them and how long they're going to be up for, we estimate 2 to 3 years. And then you can interchange the panels, so that, for example, if you cause damage to one, you can just replace one rather than having to replace them.
Well, I'm guessing that the tents will probably retain a little bit of heat as well, just a little bit, or just, a little frost tolerance or something like that. So I could see them as like an opportunity to just kind of like extend the growing season for specific varieties in the breeding program. So one of the challenges you always have as a breeder is when you're trying to make a cross between two varieties and then they don't flower at the same time. And then you can get over that by stagger planting the earlier maturing varieties so that you get something that's going to match with the later maturing variety. But then if the growing season is too short, like you're going to have a hard time extending the season. And it's not practical to build like a greenhouse around just your specific rows where you made the cross. But if you had like a modular tent or something like that, that would work great. We have in the past used like this floating row cover to kind of help with that, and it works okay, but it's really, it blows around in the wind. It's hard to keep in place. It's not, I guess we could like try to invent like, some kind of metal frame, and then fasten the floating row cover on top of that. So there's things that we could do, but it'd just be nice if there was like a canned thing that you could just go to and you just knew that this is going to work. And it would also be great if when you're making those crosses, you didn't have to put a paper bag over it. Like you could make the cross with a paper bag just to transfer the pollen, but then you could let the hybrid seed mature without the influence of the paper bag on it, which might actually increase the seed set. And so that would be something that I would really be interested in testing as well.